All right, so in number 7, you have a plank that's being held up by two cones, but the cones aren't on the very end of each plank of the plank. And you've got a person who is on one end here, and for part A it says, to what distance can a person who weighs 450 newtons walk on the overlapping part of the plank before it just begins to tip? Well, when it just begins to tip, that means that this side is just coming off. Like right now, if this person wasn't even on the plank at all, some of the force would be supported by, some of the plank's weight would be supported by this cone, and some of it would be supported by this cone. So I want it where I can literally take that out and it would still stay there horizontal. So since I'm going to actually do my free body diagram, I'm just going to use the picture. And you can do this if the picture is big enough and you can fit everything in. So what I'm going to do here is I am going to put the forces that are on this. Now it says that it is a uniform plank of length 5 meters. So if it's uniform, it means its center of mass is right in the middle. So the weight of the plank is right in the middle of the plank. So I can make a force straight down, and that's going to be the weight of the plank, and I know what that value is, so I'm going to put it in. It's 225 newtons. Now, this person is walking, their weight is over here. So I'm going to have them right there, and they have a weight of 450 newtons. Now, at the point when I could remove this, when there's no force here, would be when these two together balance. Like if this balances that, then I don't even need this here. I only need this if I need another arrow up to balance things. So really, it'd be if the person was not on here, if they weren't on here, I would have a force up on this side and a force up on this side. And since the cone is closer to to the center of mass than that one, this one should be more of the weight than that one. But in this example, we've got a person who's on the plank. So that's my picture. So my center of my pivot point I'm going to use is right there, because that eliminates that force which is happening where the cone is. And so if I sum up my torques, I know that they have to add up to 0. And so this force is making it go clockwise, so this one is going to be a minus. So it's going to be minus 450 newtons times its distance to the pivot point. Now that's the distance we don't know. We know that to the end of the plank is 1.1, so I'm hoping that it's less than 1.1, or you're not going to be able to balance it, because the person would have to be off the plank to be the correct distance. So hopefully it's within the value of 0 to 1.1. And so so this distance right there, I'm going to call that x. Call it whatever you want. Call it L, call it x, but that's the thing I don't know. And then the weight of the plank is making it go counterclockwise, so I know that's going to be plus the weight of the plank times its distance to the pivot point, and that's going to equal 0. Now I need to figure out its distance to the pivot point. I know that if the plank is 5 meters long, then that is 2.5 meters, because that's half of 5 meters. So I know that it's 5 meters from there to there. Well, if that's 1.1 and the whole thing has to be 2.5, then what is my distance from there to there? 1.4. So that's the number, because now this is where the weight of the plank is. That's the pivot point. So that's the number I have to use right there, 1.4 meters. And now, solving it for my unknown, I guess I'll move this thing to the other side and then solve x. But I like my unknown on the left, so I'm going to have x is going to equal 225 newtons times 1.4 meters divided by 450 newtons. And that gives you half of 1.4, so that's 0.7 meters. All right, so that's the answer for part A. Now for part B, I'll do it in a different color here. For part B, how much of the plank's weight is supported by each of the supports if the man steps off the plank? So in part B, we're going to say that this guy is not there. And so now, you've got, well, I probably should make a new picture here. So let me do that. Actually, let's see what I can do. I'll just make my diagram for part B. So rather than use the picture. So I'm going to have there's my plank. I am going to have a force on one end of the plank due to the cone that's on the left side. I'm going to have a force on the other end of the plank, and the weight is in the middle. So this number is still 225 newtons. This distance is 2.5 meters. This distance is 1.4 meters. And this is, I guess, we'll call this the left cone, and this is the right cone. So if I want to get the left to the right, I'm going to make the left the pivot point to solve for the right, and make the right the pivot point to solve for the left. So I'm going to, let's say I make this the pivot point. That's going to help me solve for the right. Because if I sum up my torques, I'm going to get this one is making it go clockwise. So that's going to be minus 225 newtons times 2.5 meters. Because that's how far it is to the pivot point I'm using. The other one, the right cone, is making it go counterclockwise. So that's going to be plus the right one, which I don't know what that is, but I do know how far away it is to the pivot point, and what number should I use for that? 3.9 meters. 3.9 meters because we have to add 1.4 plus 2.5, so it's 3.9 meters, and these all have to add up to 0. So if I solve for R, I'm going to be moving this to the other side and then dividing it by 3.9 meters. So it's going to be 225 newtons times 2.5 meters divided by 3.9 meters. And if you do that, what do you get? 144? Okay, 144. Now I can do the exact same process to get the left side by just moving my pivot point from there to there, or I can say, since I know this number right here is 144 newtons, I know that the two forces up have to equal the force down. So if I subtract 144 from 225, I'll get that value there, which ends up equaling what? 81 newtons. So that's doing it without actually doing a torque problem, just knowing that my forces up have to add up to my force down. So these two together have to add up to 225. Any questions with that?